So, we're all on page 263, I hope. And if you notice, this whole unit is solving linear inequalities. And today we're doing one-step inequalities. So linear means they would make a line, and inequality means it doesn't have an equal sign in it. So what we've been working with are something called equations, and that's because they have an equal sign in them. Inequalities are these symbols right here, okay? So these are the symbols that we call inequalities. Okay, we have this one, we have this one, we have this one, and we have this one. Okay, so what are the differences here? Well, the first two are less than symbols, and I'll tell you a way to help you memorize this, but less than or less than or equal to. That's how you say this symbol, less than or equal to, okay? Where this is just less than, that's less than or equal to. How can you remember that these are the less thans, and this one, these two are the greater thans, greater than and greater than or equal to. So if you try to make the less than symbol with your hand and then open it, it makes an L, okay? So that's how you can remember that these two are the less thans. Because you have to know that, all right? It's really important, okay? So these are the less, and these are the greater. And notice it says one step. I mean it when I say one step. Like, these are just, if you guys know how to solve equations that have one step in them, then you know how to solve inequalities. There's just one little thing that we have to be super careful of with these, and I'll show you what I mean when we get to it, okay? So let me introduce the first example to you. Here it is. Let's put it over here. You know I can't stand the way they do these notes. We have to solve this inequality, which means get x by itself. You guys would do the same exact steps with this problem if it had an equal sign in it, okay? Absolute same exact steps. So what would the first step be? Nope. Delaney, do you know? Oh, guys, come on. What do we do to get x by itself? Yeah. Alan, we're not subtracting when there's a minus. Come on, guys. We always do the opposite. Delaney, does that make sense to you? Okay. So add 10 to this side, add 10 to this side. You want this? You two, let me just put this here. You need to rip out these pages. That's what we just did. Okay, so add 10 to both sides. So I would have x is less than, right? Remember the L? And then 15 plus 10, write my calculator if I need it, is less than 25. So what an inequality is, let's compare it to what x equals 25. When it says x equals 25, when in the last couple of units we did equations, it meant x is 25 and that's it, okay? This means x can be anything that's less than 25. 24, 23, 22, 21, negative 5 million. Can it be 26? No, because x has to be less than 25. When you read a inequality, whether you're reading it in your brain or out loud, you always start with the variable. So it's always x, okay, it's going like that makes it L, is less than 25. X is less than 25, okay? Now, there is something called set builder notation, and you are going to be writing your answers in this way. So let me show you how to write it, and then I'll tell you how to say it. If you hear it, you know that's what someone is saying. You have to start by making some like fancy little brackets. I don't care if you make good brackets or bad brackets, just try, okay? This is not life or death here, but that's what the bracket looks like, okay? But don't stress if yours doesn't look good. Mine's not even that good, right? Whatever the variable is that's in the problem goes right after, and that variable will change. You just match whatever's in the equation, right? We've seen lots of equations or inequalities that have x or z or r or p or whatever. And then there's like a straight up and down line, and then you write the answer. This is called set builder notation, and close it with your fancy brackets. That's how you're going to write your solution. The way you say it is the set of all numbers x. So the set of all numbers x such that x is less than 25. That's not something you will have to say. I just want you to be familiar with what it sounds like, but you should know how to write it. And we'll practice that on the next few problems as well. You got this? Alexis got it? Sally got this? Okay. All right, let's try another one. Sadie, do you know what I would do first on this problem to get x by itself? Divide? Okay, so it seems like we're struggling with this, these one-step equations or inequalities. Listen, here's a trick for you, okay? So if you look at a problem and you're like, oh, I don't know what I should do. I know it's supposed to be opposite, right? So if you read this out loud or in your brain, you would say this. Every single one of you can read this and say x plus 24, and then you're learning this is greater than or equal to 61, right? X plus 24. When you hear yourself say plus, what's the opposite of plus, Sadie? Yeah, exactly. Good job. So opposite of addition is subtraction. So sometimes when you look at it, you might not be thinking plus, but if you say it to yourself, I mean, every one of you would say x plus 24. All of you can read that. And we should know that the opposite of addition is subtraction and vice versa. So if this was x minus 24, then we would add, okay? So subtract 24 from both sides, right? So those cancel. And we would have x is greater than or equal to. That goes right in your calculator. And you get 37, thank you. But remember, we're going to write our answer in set builder notation. So you make your fun little fancy bracket. They're using the letter X, so slowly. That vertical line, and then you just write the answer. Now, you heard me read this problem as x plus 24 is greater than or equal to 61. It is really important, even though you're not saying these words out loud as you work on this problem, that you start memorizing which one is which. It is very important that you know these, okay? So, guys, there's basically two. One of them is less than, one of them is greater than. If you know the trick for one of them, you only need one trick, because if the trick doesn't work on the other one, that's the other one. So don't forget, if you make that symbol with your hands and then open, or your fingers, and you open your fingers, it makes an L. And L starts, or less starts with L. So these are the less thans, these are the greater than, okay? So when I saw this and it didn't make an L, I know it's greater than. And when I taught the younger grades, but still holds true, we would say the alligator eats the bigger number. So X is greater than. So he's hungry, so he wants to eat the bigger number. X is greater than. So whatever works in your head, just you have to know it. Okay? Now, I need to show you something else in this example right here. So remember I said these are pretty simple. They're one step. But I said to you at the beginning, there is one nitpicky particular thing we have to be super careful of with these problems. And it's going to show up in this one. Okay? So still, we're just solving for x, right? Just like you have for months with me. What's the first step, y'all? Subtract, right? If you read this to yourself, 88 is less than x plus 13. Let's just look at the side. X plus 13. When you hear yourself say plus, you should know that the opposite operation of that is subtract, right? Do that to that side and the other side. So I would get 75, bring my symbol down, bring my x down, bye-bye to the 13s, and we're done, right? We got x by itself. We solved it. But here's that thing I was telling you about. whenever we write the final answer of an inequality, you always want the x on the left-hand side, okay? So we didn't do anything wrong. It's just the x happened to be on the right-hand side. So right now is where we're going to, what I call, flip it like a pancake. Listen to what I'm saying. Imagine if I could take a spatula and scoop under this last line of the problem and flip it over. What would happen is the x would be over here and the 75 would be over here, right, when you flip it. And what would happen to the symbol? It would also flip, right? Instead of it pointing to the left, it would point to the right. That step right there is what number one mistake students make with inequalities, is when they flip it, they just flip the number and the letter and they forget to flip the inequality. Go back to the alligator. The alligator should still be eating what he wants to eat. In the green line, he's eating the x. In the red line, he's still eating the x. That's how it should be. Or think of it as pointing to the 75 in the green, still should be pointing to the 75. That is what you would write as your answer in set builder notation. Okay. All right. Let's look at example 2. When we learned how to solve equations, and when we were really in the thick of it, you guys did really well with it. Let me remind you that we started like day 1 in this class doing one-step equations, and then we kept adding onto it to the point where we had lots of steps to do, but you guys were really good at knowing, oh, if there's parentheses, I would distribute. And then if there's like terms on the same side, I would combine those. We don't have either of those situations here, right? There's no parentheses. There's nothing on the left-hand side that I can add together or the right-hand side. The next thing to look for, we do have, and that is, are there variables on both sides? And there are. Remember, I would make my dumb little joke of when it's x's, get your x's together, just not in real life. Same idea. We're going to get our y's together here. So let's rewrite it right here, please. Now, guys, listen to me. That's a lie. This is a 2-step equation, actually. Oh, no, it's not. It's one. Okay, forget it. Anyway, it's 1 step. We have to get our y's together. Now, just like I told you before when these were equations, it technically doesn't matter which one you start with, except be smart about it. If you want y to be by itself, which one does it make sense to move? The 9y or the 10y? One of them is a smarter move. 9. Does that say that, Gabe? Okay, so the problem, he's right. If I move the 10y over here, then I'm going to have a 0 over here. And I'm not solving the problem. Remember, the goal is to get y by itself. Why would I bring this y over with the 3? I want the y's to be together by themselves. So even though you don't like putting your y on that side, that is the better choice. So you would subtract there. How did I know to subtract? Because it's positive. And when you do this, you want to cancel them. What we do to one side, we must do to the other. So I have 3, that's a positive 3, is greater than or equal to 10y minus 9y is 1y or y. Now remember, we have to flip it like a pancake. So the y and the 3 switch places. And we have to flip the inequality symbol. Okay? Set builder notation. It's switched to a y, so we have to put y there instead of x. Okay? And last example, we do have to do a word problem. These word problems can be a little tricky, so please listen. We're going to do this last one, and then I'll give you your homework, which is not long. If you finish your homework in class, which you should, and you have not done your EDIA, my recommendation is you get your laptops out and do it. Some of you have 2 zeros already for this. This is week 3. Some of you have zeros for week 1 and week 2, and there's no late. I give you a whole week. I give you class time. You need to be doing it. Doesn't take very long, okay? All right, let me read example 3 to you. Use an inequality to solve a problem. Hassan's wireless contract allows him to use, this is a very important term, at most 5 gigabytes of data per month. At this point, Hassan has already used 3.7. So he's allowed to use 5, and he's already used 3.7 of that 5. So we're going to write an inequality to find how many gigabytes of data can Hassan use during the rest of the month without going over his maximum allowance of 5. Okay? So he can use at most 5 gigabytes, right? That was given to us. They're going to give us a variable of g. G will equal the number, it's not hashtag, that's number of, and that's the abbreviation for gigabytes left to use. Okay? I don't really like all these spaces, but think about it. If you have, he's already used 3.7, how much more can he use? We'll call it G, right? 3.7 plus G, and then we're going to put a symbol here, and then this is going to be 5. Now, back to the word at most. The words at most, this is where some students get confused. Tomorrow I'll introduce another term to you, which is at least. But at most, think about it. Is that going to be, it's got to be one of these 4 symbols, okay? At most. So talk yourself through it. Can he go above 5? Okay, so that, if he's not allowed to go over 5, and you're right, whoever said no, he cannot go over 5. Remember, that's the max. Then that's going to get rid of the greater thans, okay? So he can't go above 5, all right? Can he use less than 5? Is he allowed to use less than 5? Yeah, right? It's almost common sense. At most means he can use 5 or less, right? 5 or less. So that's going to be less than or equal to, because you can use 5 or anything less than 5, okay? So let's solve it. You would subtract 3.7 from both sides. I know it's a weird looking equation. You would get G is less than or equal to, I put this in my calculator and got 1.3. So the number of gigabytes that Hassan can use without going over 5 is 1.3 or anything less than that. He can use less, but he only has 1.3 gigabytes left, okay? So these take a little bit of common sense, right? And so they're a little tough times. I gave you 1 in your homework to try. All right, let's go to the homework. So I'm going to put the answers up here. You'll have the answers. They are not, I did not show any work though. So make sure for credit. And if you go look through your packets, if you didn't get 40 out of 40 this week, look and see what, I write everything. It takes me a long time to grade those packets because I write on there 0 out of 4, 1 out of 4. If you didn't show work, I didn't give you credit. You have to show work. You can't just copy my keys. You're not learning anything or really doing anything except copying. So I'm going to show you the answers. You will do the work. Okay? And I think you have enough room on this paper to do it. But if you want to use another sheet of paper, you're always welcome to. Just make sure you turn it in when I collect it. Give me a minute and I will come around and check on y'all. Yeah.